Hey everyone, just looking to let a couple people filter in here while we get ready to go. So a couple minutes. All right, so I am here with Zach, our head of growth, and I'm John, our product manager here at Union. And I wanted to run through what we've been cooking up here at Union on Flyte 2.0. So we had our launch event back in July, got a bunch of interest, and wanted to kind of just give the community an update as to where we are, and kind of highlight some of the great features that we've been shipping. So I have a deck here. This is going to be mostly me running through code. And so let's get started. So just to kind of set the scene, like what is Flyte 2.0? We reimagined Flyte to be a durable, dynamic, resource-aware AI orchestrator. So think like this GIF I have on the right here, the ability to dynamically override resources in response to like out-of-memory events, and be able to kind of self-heal your workflows and actually do any kind of thing that Python would enable you to do. Kind of combining the orchestration logic with the compute, and making that this durable, fault-tolerant system that's really easy to develop on, and kind of just magically scales out to many containers as the user wants to build their ML pipelines and their agentic workflows. So I've got a little agenda here. Just wanted to kind of show some of the stuff we've been working on. I'm going to cover notebooks, so the ability to author workflows in Jupyter and Colab, being able to show metrics for jobs, so kind of like CPU and GPU resource metrics for any task you run. And then we have a reincarnation of a beloved feature called Flyte decks, which are now called reports in V2. Wanted to show a little bit about compute plugins. And so a lot of folks run Ray and Spark workloads natively on Kubernetes using Flyte to orchestrate. And so we wanted to show like the way we have built like a really nice deep integration with Ray. Wanted to demo remote debugging, which is the ability to spin up a task instance with the data inputs hydrated in order to kind of step through your code and see what's going on. And then finally, demo reusable containers and actually concurrency and auto scaling of reusable containers. So a way to achieve like really fast performance with Flyte. So let's jump in. So notebooks, and I'm actually going to switch my context here just to a notebook. I hope everyone can see my screen as I switch tabs here. I'm sure Zach will tell me if you guys can't. But this is just, I have like the most simple notebook ever that creates a data frame and actually uses a task to create this data frame and returns it. And then I actually want to go and get the data frame and pull it back into my notebook. So this is kind of like, the most basic possible data science workflow, but kind of thinking of the notebook as this hybrid of local compute as well as, big remote compute if you need to run your workflows. So we import Flyte. I can run this init from config command. And if you notice here, I'm using AWS to do for my object store. And so this kind of gives me a native abstraction on top of my object store that lets me get stuff out of it really easily. I'm going to create my task environment. And this is a way of specifying your the environment in which your task is going to run. So here I gave it a name, and within my image, I just said, I'm using this Debian base, and I'm going to use pip packages, pandas, and PyArrow, which help me get that data frame. So I'm going to create my environment, and then I'll be able to define this task directly in Python. So I just kind of have my environment.task. I have my definition here. This is going to create a task, and then I can actually run the task remotely, complete with image building. So I've actually already built this image, and so it's just going to use this cached image. I can get the URL for this run. This is going to be like a real run that's happening right now. It's going to create this data frame. You'll be able to see the output is of this like structured data set. We're renaming this to data frame to kind of be more clear, but this is kind of your classic Flyte IO treatment. But here I'm able to go and dynamically pull inputs, outputs, protobuf representation of those outputs. I can grab the Flyte data frame FDF out of the output 0 tuple or out of the outputs tuple, and then I can actually just await this and pull it directly down as a data frame into my notebook. So we wanted to make Flyte much more native and friendly to data science users who might not be whose native kind of environment might not be the IDE, and we wanted to make it really easy for folks that run Flyte as part of their platforms to directly enable data scientists to take advantage of those powerful infrastructure resources that they have in the cloud, while still having this secure and seamless user experience around getting stuff in and out. There's definitely more to show here. I can watch the workflow. I can actually stream the logs out of any individual action. So basically any attribute that we can show you in this user interface is available in the remote SDK. So we wanted to make this like really, really straightforward. So that's the first example of notebooks. The next thing I want to cover are CPU and GPU metrics. So I have this example here called GPU metrics. I'm actually going to run it while I talk so that I don't wait for it to run too long. So I'm going to run this one. And so this will kind of kick this up, and I'll show this as it goes. But this is just going to do like a really straightforward, it'll build an image that contains PyTorch. It'll grab a GPU, and it will do some matrix multiplication on that GPU. I think I have it set to do this for 120 seconds, just so I can have enough time to collect some metrics data about what's happening. Might have had an earlier run here to kind of quickly see what's going on. Let me see. Yeah, anyway, I can basically show these metrics here. So what we're doing is we're running a we're running a metrics collection infrastructure inside the data plane, and we're able to show you your memory, used allocated limit, as well as like your GPU memory allocation, your GPU utilization, your SM active cycles, and your SM occupancy. So perhaps these aren't the most interesting right now. We actually collect the data every 15 seconds. And so that's why I wanted to have this task run a little bit longer, but here's just like a quick example of how to do this. Moving on. So I have reports. And so reports are this really awesome feature that people use really heavily in Flyte, and think of them as a way of any kind of like print statement you throw to basically do some matplotlib or any sort of like data visualization, static data visualization can be achieved with reports. So I have an example here where we go, sorry. Reports. And then I can say Python run all.py. So this will just pull in a bunch of different report examples and run them all at the same time. I think I may have even run this earlier. Let's see. I'm actually going to run this example for posterity while we wait for reports. Anyway, these will run in a sec. So what this is actually also an example of reference tasks. So if I go to my reports example, if I go to my reports, I'm actually able to show how I can pull in all of these other scripts into my one script and run it as a task. So I've got a report that shows, a network graph. I've defined this in HTML, and I can run this. I can also, pull this network graph. Actually, maybe that's not a good example. I can pull Protein 3D into my environment by having my environment explicitly depend on these other environments, and then be able to access the task directly from the environment object and then run them all. So here's what reports look like. It's kind of elevated here to a tab in the UI. So we wanted to make it, Flyte decks had a discoverability problem where they perhaps weren't as easy to, not that many people knew that they existed. We wanted to make reports like this really obvious to users that it's a tool in their toolbox. And so here's just kind of an example of what's possible. So you can create these interactive dashboards. You can create like Claude was very helpful in generating a lot of this HTML, I must admit, but creating some of these really awesome, globe visualizations, satellite images, kind of interactive scatter charts, able to kind of, move around protein structures, and even a YouTube video embed, which is watchable with audio. So reports, super powerful. Some of these examples are perhaps the most crazy version of reports, but you kind of get the point. Anything that you can save in a static HTML file will be viewable right here. The other nice thing about reports is it's secure. So it's kind of stored in your object store, and then we use a data proxy to pull this out and just show it in the UI through an encrypted channel. Okay, cool. So that's reports. Let me see what's next on my agenda here. I'm going to show Ray. So I ran this Ray job here. Before I did this, I actually like ran a Ray job just to kind of get this process of spinning up the Ray cluster started. So I'm going to demo this and then I'll go back to the code to show you what's going on. But this is a Ray task. It's using the Ray plugin. We've built this really clean integration that manages the life cycle of these dashboards. So I can actually show this dashboard directly in the UI. I can go and look at my Ray tasks running. I can see, all of the logs and kind of everything that Ray provides out of the box for managing the jobs. And once this completes and succeeds, this Ray dashboard link will, be grayed out. So it's, users will never get like a 502 or something. So it's kind of this nice clean life cycle around managed Ray inside Flyte. Now, what's actually happening here is I have this example. This is this Ray example that was running. And so I have Flyte plugins Ray. I was able to create my Ray config. I have my image, which is using, Ray dependencies. I have a normal task environment that doesn't have anything to do with Ray that we use for use in a minute. And then I have my Ray environment, which uses the Ray plugin in order to the Ray plugin and the image in order to create the Ray cluster. So what happens here is I have my main bar. I init from my config. So this is just a way of setting up the remote access. And then I run this hello Ray nested task. This task is running. This task causes the Ray cluster to spin up by using Ray environment. It then will actually, from the Ray context, will create another task called hello Ray, which is what we use that other environment for. And then it will return, and then it will run some Ray stuff inside that Ray cluster. And so what this example shows is not only that Ray dashboard integration, but also just like the really clean interop between a Ray cluster that can actually call Flyte tasks from within the Ray cluster and actually get durability. So this is kind of a interesting fusion. It kind of proves that we're really just running pure Python. And we're able to kind of anything that you can do from within the Ray cluster, we can actually just seamlessly integrate using Flyte Remote. So this is a really fun Ray example. Let's see what else I've got. So I have, let's see. I'm going to skip the debugger flow for now. And I'm going to go to my next example, which is reusable containers. And so I'm going to run this. I'm actually going to kick off two things real fast to make my example better. Let's see. Okay, we're going to do this. And then we're going to do reuse. And I'm going to say, okay, so I have this, task called this workflow called reuse concurrency. This is going to highlight how I can run. I can do two things. I can share containers, and I can share the concurrent. I can run concurrently within a container. So I have this no op task. Kind of just basically proves that you can run a task, but it doesn't really have much in it. It actually has nothing in it. Just this debug line. And then I have my reuse concurrency where I'm going to basically do a fan out and do some sum over all these no ops. My environment here is where I define this. So I have my my resources. This is like, we'll define my resources for the container. And I have this reuse policy. Um, and what this is going to do is going to spin up two replicas. So two different containers, each of which have one CPU and 1 GB of memory, which will stay alive for 60 seconds. Which means I have to keep running this if I want that environment to stay hot. I have 100 concurrency, which means I'm going to run 100 of these no-op tasks concurrently. And then there's another TTL parameter here that will show the auto scaling aspect. I can also have a tuple here and say like, I can have auto scaling is built into this as well. This example, I'm not going to use auto scaling. So what's happening here is I can run 500 tasks very quickly. I can actually kind of just demo to show you like the sort of stretches our UI's ability to show all of these tasks. And we actually are working on visualizations for bigger fan outs. But just kind of being able to show you by rerunning this task, like you're able to run, you know, very, very quickly many of these tasks. I'm actually surprised it's taking this long, but yeah, you can essentially run, you know, 500 Flyte tasks in, you know, 20 seconds. And I've seen this run faster. I'm not surprised, not sure why it took so long, but basically just being able to really, really quickly run stuff by sharing containers and reusing. And so this essentially opens up a lot of use cases for faster, kind of like lower latency workflow requirements. And so being able to run agent workflows with users waiting on the other side, being able to run, even just being able to like efficiently share containers to get higher GPU utilization, which is an example I'll show you in a bit. This is kind of just like a quick example of concurrency. And I have one example to kind of pull it all together. So let me show this other one where we did embed Wikipedia. And so what's happening here is I'm gonna embed the English version of Wikipedia. And let me see where I am on my original one that I kicked off, because I think I can run this pretty fast. Oh, it cached. That's the problem. I'm going to do this without caching. So that is actually, I guess, a demo of another feature that works really well, which is caching. If you try, it's bad for demos, but it's good for machine learning engineers. If you have caching on and you try to run the same task with the same inputs, we will just look up the output. So I think what I can do here is say, I'm actually going to do something a little bit strange. I might actually do something really hacky, which is like cache bump, because I don't remember how to change the caches. I'm going to do this is ML, and I'm going to say actually this isn't going to change my cache at all, but I'm going to go look up another version. So let me see if I did this. I think I ran this earlier. That was 0 seconds. A lot of runs that happened previously. Actually, I already had this open. Did I? Yeah. So like, here's an example of, I ran it yesterday. This is whose cache I'm reading. I am running this on, okay, back to my embed Wikipedia example. Sorry for the derailing. I basically load Wikipedia articles using the Hugging Face datasets library, do some pre-processing, generate embeddings, and store the results. I've got my image here, which is going to use this Union AI reuse package. I have my driver, environment, which is going to grab the data from Hugging Face. And then I've got my worker environment, which will actually do the reusing. So this spun up 16 replicas of this 2 CPU, 8 gigabyte of memory, 1 GPU task or container, sorry. And I was able to run, all of these like pretty quickly and efficiently. So what's happened here is I've sort of sharded out the different like sections, and I'm going to do embeddings on them. So just kind of picking a random one. This one took a while to set up because it was waiting for the GPUs to spin up from 0. Once those spun up, we were able to really quickly download the image and run in 11 minutes and 56 seconds. I've got all my inputs and I've got my outputs, which is this, data set. I can show the metrics over time. So this is perhaps like a better demo of the metrics data, being able to see, how my GPU utilization was going. And we're working on kind of getting this utilization to be even like, closer pinned at 100. And then, showing like the SM occupancy and the SM active cycles, which are both arguably better metrics than what NVIDIA calls GPU utilization. This demo also shows some recovery aspects. So this particular action failed due to some system, the pod died or something. No worries, it basically will, it'll automatically recover, and you'll be able to see through the attempt picker, like how it went after it recovered. So, and we'll preserve the metrics for both, but you can go through and look at, all the metrics from every one of these. So this is a example of how to embed Wikipedia, getting that, observability of all of your metrics, being able to break your computation across multiple GPUs, but actually also share the containers. So you can see, for instance, that, this task ran really quickly. It maybe waited 6 minutes to get a GPU and then completed in 7 minutes and 49 seconds. If you look at some other longer running tasks, like this one was waiting for resources for 21 minutes. So it was basically waiting for one of those worker containers to become available, at which point it completed. And then one other thing that I forgot to show earlier is we're using Python's native LRU cache to load the model. And so what's happening here is in Flyte 1.0, you're always going to be loading every task is like completely isolated, and we'll always like spin up the infrastructure, create the container, download the inputs, load the model into memory, and then do like whatever like single operation is contained within the container code. In this world where you're reusing containers and you're running in like a pure Python environment, we can actually just use native Python constructs like LRU cache in order to load this model into the container's memory. And as you have new tasks that are running, it'll just, leverage that model. So you're not paying the cost to, spin up and run. And so we're able to get this runtime really, really fast. So that is pretty much it for the September update. I have a slide that I can go through here. This link takes you to a page that lets you sign up for the Flyte 2.0 beta. Everything you've seen here is Flyte 2 running on Union. we're in this really fast iteration mode where we're able to kind of break things and figure out the right shape of the data model and the way things work. And so we're taking the opportunity to do that temporarily in our kind of union environment. And we plan on open sourcing so the SDK, everything you've seen here is open source. So this Flyte SDK repo is inside Flyte. The UI and the back end is currently not yet open sourced, and we're working on a version of the back end that runs really cleanly on Kubernetes, and we'll have more information and designs coming up really quick. And so in terms of just like the timeline and the roadmap, we're looking to get Flyte 2 on Union GA coming up within the next couple weeks. That's going to be followed by kind of an open source design for the Flyte backend, and getting a version of the Flyte 2 open source backend that's usable out. Usable but not GA, potentially around the end of this year, and then looking at GA of Flyte 2 towards the beginning part of 2026. So that's just some quick verbal timeline information about what we're working on and what's going on. I'm actually not able to see any questions, so if there are any questions, I might rely on Zach to give me some. Otherwise, I can say thanks for everyone's time. Thank you.